the lab?
We're currently in the Department of Mechanical Engineering, in my lab, the avalanche lab.
While you won't find any snow inside this avalanche lab, you will find snow experts like Natalie Vriend. Vriend is an associate professor in mechanical engineering at CU Boulder. She's been studying avalanches for more than a decade.
They go so fast that you're kind of in a bad spot if one is coming above you.
While we often see the dramatic images of avalanches, not much is known about what really happens inside one. That's where Vriend and her students come in.
So these are photoelastic particles that we're using in our scientific research here in our lab.
Using these particles to mimic snow granules.
In the faster rolling regimes, the force chains go more up the side, flying down the chute.
The scientists conduct small-scale avalanches to get an up-close look at how snow behaves.
So imagine this is a small snow granule that runs down a slope. At that moment we can investigate what the physical laws are, how this behaves. This is a rotating disk, and we're using this as an analog of a small avalanche that keeps going, like it never stops.
Yeah, it's basically my job to investigate how particles flow with really cool camera gear.
For PhD student and avid skier Ryland Hodgson, it's a chance to solve a bit of Earth's mystery.
We're kind of at the mercy of the Earth, so we should probably understand how it moves.
An avalanche occurs when temperature variations cause the snow to melt and refreeze. That snow then becomes more granular, forming a weak layer. When snow falls on that weak layer, it can slide. Inside the lab, the engineers track photoelastic particles with this high-speed camera to see how the particles bounce and collide. They found those collisions are happening really fast, within 1/1000th of a second. In a real avalanche, collisions like that would create so much heat, the snow would melt, refreeze, and lock the snowpack in place like concrete. Researchers can also look at the particle movement to better understand where the slides are headed.
If we understand the physics of avalanches, at that moment we can also predict better where avalanches are going, what kind of force are exerted on structures when they're being hit, and what kind of mitigation methods we need to take in order to reduce the danger and the hazard of avalanches.
And with the record warmth we've had lately and a changing climate, understanding the physics of an avalanche is more important than ever.
If you now suddenly have climate change and a different weather pattern, then you might get avalanches at spots where typically they would not have happened. And that is very dangerous.
In Boulder, meteorologist Keely Chalmers, 9 News.
It's fascinating and so important that we get a handle on this as we continue to move forward.
Oh yeah, and the warnings are so much better and the equipment's so much better, Kathy. You would hope that we would all be much more prepared because of the warnings alone.